Hello all, I hope you're doing well. In this video I would like to start talking to you about polyvagal theory, and what I wanted to share with you today is a part of an article that is titled Polyvagal Theory Summary, Premises, and Current Status, that is from February 2023, and it can be found on Polyvagal Institute website. It is free to public. I will be breaking down, sharing this article into 3 sections because there is a lot of information. And today I will be sharing the summary portion. In the next video will be premises, and lastly current status. The reason I wanted to do this is because there is a lot of debate whether to use polyvagal theory in practice among practitioners that deal with variety of healthcare issues, including mental healthcare issues and specifically trauma work. So without further ado, I will be starting. Autonomic state as a neural platform. Polyvagal theory conceptualizes autonomic state as a neural platform influencing behavioral, physiological, and psychological responses. Rather than assuming a cause and effect or stimulus-response model that assumes a psychophysiological parallelism, the theory proposes that autonomic state functions as an intervening variable mediating the response. Hierarchy of autonomic states, an emphasis on 2 vagal pathways. The model can be conceptualized as a stimulus-organism response model in which autonomic state is expressed and experienced along a continuum from fear-related immobilization involving dorsal vagal mechanisms to fight-flight mobilization involving sympathetic mechanisms, and finally to a calm, socially accessible state involving ventral vagal mechanisms. This sequence is hierarchical, with the latter state functionally having the capacity to co-opt the other states to enable hybrid states of mobilization without fear, such as in play or dance, and immobilization without fear, such as in cases of moments of intimacy, shared moments of intimacy. From an evolutionary perspective, the sequence is a hierarchical representation of the evolutionary history of the vertebrate autonomic nervous system as it became encoded in the autonomic nervous system of humans and other social mammals. The newest circuit, dependent on the ventral vagal complex, is the product of a ventral migration of cardioinhibitory neurons in the brainstem to the ventral nucleus of the vagus from the dorsal nucleus of the vagus. This ventral migration appears to have been completed in the earliest mammals as a defining characteristic of their transition from ancient extinct reptiles about 220 million years ago. The integration of cardioinhibitory neurons into a ventral vagal complex provided a circuit that integrated suck, swallow, vocalize, breathe processes with newer mammalian myelinated cardioinhibitory ventral vagal pathway that is expressed as RSA, or respiratory sinus arrhythmia, in the heart rate pattern. This circuit, which initially links ingestion through nursing with behavioral calming, provides the basic structure that enables co-regulation and connectedness through the lifespan. According to the theory, survival challenges trigger a process of dissolution or evolution in reverse that disinhibits the phylogenetically older defense circuits of fight, flight, or freeze collapse. Dissolution disrupts homeostatic functions and predisposes visceral organs to disease. Within the PVT model, disruption of homeostatic functions, by the way, PVT is polyvagal theory, operationally defines a physiological state of stress and psychological states of anxiety and threat. In contrast, when ANS, or autonomic nervous system, successfully supports homeostatic function, feelings of safety and opportunities to co-regulate and connect are spontaneously emergent. PVT is an integrative model emphasizing brainstem regulation of ANS. PVT does not preclude the important influences of both bottom-up signals from the body to the brain through interoception or top-down influences via memories, visualizations, or associations on these regulatory circuits. And you could certainly look for the definitions of interoception, neuroception. I can provide those as well in the post section on this channel. Retrospective context. When initially formulated, this is from Porges, 1995, and there's some other quotes that are from Professor Porges in this article. PVT was conservatively organized upon several premises or inferences extracted from the literature. These premises were plausible explanations of important phenomena observed in psychophysiology and in perinatology, for which neurophysiological mechanisms, had not been identified. By proposing these premises, the scientific community could confirm or refine these inferences through more in-depth exploration of published literature and empirical research. The premises of PVT provided a new framing of questions that tied the neuroanatomy and neurophysiology of ANS to clinical conditions and psychophysiological processes. PVT focused on a plausible explanation of the, quotes, vagal paradox into disparate disciplines, perinatology and psychophysiology. Functionally, how could the vagus be the pathway for both RSA, respiratory sinus arrhythmia, and bradycardia, which is decreasing of a heart rate? The publication of the premises functionally framed the scientific questions for subsequent empirical research to evaluate specific clinical conditions and psychophysiological processes in which this paradox was observable. By proposing plausible relationships and identifying the specific metrics to map ventral vagal, i.e. RSA, and dorsal vagal, i.e. bradycardia function, the research in these disciplines could incorporate deeper neurophysiological understanding of the mechanisms underlying these observations. With this new perspective, it was optimistically hoped that vulnerabilities could be monitored to improve clinical outcomes and predict behavior. As a heuristic exercise, we can evaluate how these premises fit with the documentation summarized above. However, first it is useful to ask, number one, how has PVT been accepted within scientific community? Number two, is there a need to revise the initial premises published in 1995? And these are the main two actually listed here. The theory has been well received in science. Google Scholar documents as of December 2022 that the foundational articles explaining and expanding the theory have been cited in more than 14,000 peer-reviewed articles. Virtually all these articles are supportive of the theory or use the theory to support their hypotheses. In addition, from 1975 to 2013 peer-reviewed research, competitively funded by National Institutes of Health, continuously supported development and testing of data contributing to PVT. These facts confirm the overwhelming support of peers within several scientific disciplines. It is important to place the stated initial premises within the context of the science being conducted during the early 1990s. During this period, the theory was driven by prominent research questions in the two disciplines in which I was working: developmental psychophysiology and perinatology. Within psychophysiology, and especially in developmental psychophysiology, there was an interest in identifying in preverbal infant the mechanisms mediating transitory heart rate changes, including those that occur in response to changes in stimulation. These responses were often associated with orienting and were frequently labeled cardiac orienting. This is from Graham and Clifton, 1966, Jackson et al., 1971. From 1960s through 1990s, the investigations of cardiac correlates or components of classical conditioning and orienting, and I'm sure this is has to do with orienting reflex they're mentioning, and defense responses were prominent, e.g. Clifton, 1974, Hare, 1972, Schneiderman, et al., 1966. In fact, my studies in the early 1970s with newborn infants evaluated transitory heart rate responses in newborn infants as indices of attention, orienting, and associative learning, i.e. Porges, 1974, Porges et al., 1974, Stems and Porges, 1974. My research also investigated the relationship between heart rate variability as a baseline individual difference and transitory heart rate reactions. In the early 1970s, heart rate variables were treated phenomenologically, and there was little interest in underlying neural mechanisms. In fact, although the sympathetic nervous system was frequently assumed to be the mediator of autonomic reactions such as heart rate, potential vagal mechanisms were rarely acknowledged. Observations of heart rate slowing in response to and in anticipation of stimulation were inconsistent with the prevalent views that autonomic reactivity was mediated primarily by the sympathetic nervous system. Although a more parsimonious explanation would be that the heart rate slowing was a product of parasympathetic nervous system through transitory changes in vagal efferent tone, afferent. I will also provide definitions of those in the post section later on. Efferent tone to the heart. However, the possibility of vagal pathways as a mechanism producing transitory heart rate responses was not a common perspective within psychophysiology. Perhaps interest in monitoring vagal function was slowed due to a lack of valid non-invasive indices or to a historical bias in psychophysiology. As a discipline, psychophysiology had historically focused on measures of the sympathetic nervous system, such as electrodermal, GSR, and the vasomotor responses. Even in the early studies of pupillary diameter, which is innervated by both branches of ANS, the focus was not on parasympathetic mechanisms, but on sympathetic excitation in explaining pupillary dilation. These biases persist. Wang et al. 2018. In the 1960s, arousal theory was the prevailing theory linking NS to behavior, e.g. Malmo, 1959. It was basically a sympathetic-centric theory, assuming a linearity among increasing SNS activation, mobilization, and brain activity. Darrow et al. 1942. This was followed by a more generalized sympathetic adrenal model of stress that focused on glucocorticoids. These are the hormones released by adrenal glands. This is from Pfaff et al. 2008 and Sapolsky et al. 2002. This view still permeates our language and implies that calming is due to downregulation of SNS, or sympathetic nervous system, and adrenal hormones. While PNS, peripheral nervous system, is that's parasympathetic nervous system, frequently assumed not to play a major role in dampening the impact of sympathetic adrenal reactions. PBT forced reconceptualization of the dynamic interplay between SNS and PNS and the potential role of the vagus as a modulator of more systemic defense systems. An inspection of first 20 years of the journal Psychophysiology, it is called, confirms that in contrast to the sympathetic neurons, sympathetic nervous system, there was a conspicuous paucity of information related to the parasympathetic nervous system and specifically the vagus. Similarly, until my research introducing HRV in the 1970s, which proposed that RSA could index vagal cardio-inhibitory tone, e.g. Porges, 1976, psychophysiology had a strong sympathetic bias. PBT introduced the possibility that two vagal circuits could contribute to the distinctly different biobehavioral roles. Although PBT provides a basis for hypotheses to be tested, regarding two vagal circuits. The ability to monitor the separate functions of two vagal motor circuits continues to be difficult to study. Initially, I approached this question from a functional level as it related to infant survival and psychophysiological reactivity. Subsequently, I looked to neurophysiology and neuroanatomy for tools to further explore and monitor these discrete systems. Unfortunately, physiologists and anatomists were not familiar with the vagal paradox and asked different questions and used different methodologies. When I ventured into the realm of neurophysiology with these questions, I was confronted with discipline-based limitations of methods and perspectives. The ability to ask questions about neural function were dependent on pharmacological blockade and surgery. Since motor fibers of both dorsal and ventral vagi are dependent on acetylcholine to communicate, selective blockages or blockade was not an option. Similarly, surgical manipulations tended to sever the entire nerve, including both ventral and dorsal pathways, as well as abundant sensory pathways that populate the vagus. I embraced these limited technologies and paradigms to explore vagal function from a perspective of physiology. In the 1980s, I used selective pharmacological manipulations to effectively block total vagal efferent activity in rats, cats, and rabbits. McCabe, ETL, 1994, 1995, Young, 1982. To study neural contribution to heart rate variability, focusing on RSA. In a quest to explore vagal regulation, I even collected beat-to-beat heart rate data during experiments in which brainstem nuclei related to vagal function were stimulated. See Porges, 1995, figures 3 and 4, pages 307, 308. Invasive stimulation of brainstem nuclei has additional confound anesthesia, since surgery is necessary to expose the vagus nerve or the source nuclei in the brainstem. The animal subject needs to be anesthetized. This led me to conduct research on the impact of inhalant anesthesia on the ANS. My research confirmed that commonly used inhalant anesthesia in humans depressed RSA, virtually independent of heart rate, in studies conducted during clinical procedure. This is from Donchin ETL, 1985, or Donkey. Initially, as PVT emphasized link between consciousness and ventral vagal function, the ventral vagus was labeled the so-called smart vagus. This was later dropped since it implies a quote, executive function, which was not the intention. The term was meant to highlight autonomic state that might optimize higher brain functions, while the dorsal vagus, initially labeled the so-called vegetative vagus, since it was involved in background homeostatic processes, as well as being recruited in survival mechanisms. In a search to learn about the vagus, I also explored the anatomy literature. I discovered the anatomists had different biases and limitations since their tools were dissection and histology and focus on structure rather than functional physiology. Although structure is important and provides insights into connection between areas of the brain and visceral organs, it is agnostic about the actual functional dynamic recruitment of neural pathways in the regulation of the organs. For example, it is possible that there are identifiable pathways from vagal source nuclei that are not recruited in the dynamic regulation of the heart, or are only recruited during life-threat situations. These are not the questions that can be answered by traditional anatomical methods. Although I searched for tools and methods to confirm the function of two vagal nuclei on the heart, investigators in physiology and anatomy were limited by their discipline methods and research questions, which were not sufficient to conceptualize the selective functions of two vagal pathways. Thus, neurophysiology and neuroanatomy, both limited by their techniques, were of little help in refining a conceptualization of the function of two vagal pathways. By the mid-1980s, C. Dellinger, ETL, 1997, Porges, 1996, we confirmed that RSA was more sensitive to vagal blockade than the previously assumed so-called gold standard of heart rate change used by physiologists. More recently, we confirmed that our method was selectively more sensitive compared to several other methods, C. Lewis, ETL, 2012, which, due to a lack of sensitivity to ventral vagal function, methodological limitations have led to faulty inferences. See Grossman and Taylor. Thus, although the neural mechanisms contributing to heart rate variability were known in 1994, the neural mechanisms regulating the temporal features of transitory heart rate responses were at best speculative. Within periodontology, prevailing clinical questions were and continue to be related to interpreting fetal and neonatal heart rate patterns to detect risk, predict outcomes, and to guide interventions to enhance survival and minimize brain damage due to hypoxia. Periodontologists are familiar with heart rate monitoring and are trained to interpret quote, beat-to-beat heart rate variability as an index of viability and the features, parentheses, slope and magnitude, of bradycardia as risk indices of hypoxia, Interestingly, within periodontology similar to psychophysiology, although these features were relevant to clinical practice, there was little discussion about the neural mechanisms underlying these phenomena. Thus, PVT was not and does not contradict existing theory in either discipline. Both disciplines tended to be agnostic to the neural mechanisms mediating the heart rate response patterns that have been used to index clinical or psychological phenomena. Rather, PVT had added neurophysiological mechanisms as an additional layer to explain these relevant phenomena. So I will stop at this, and I will continue reading in subsequent videos. I actually might make short videos where I would provide more concise information on topics related to polyvagal theory. This is what I had to share with you today. If you have any questions, concerns, comments, please don't hesitate to share those, and have a good one.